Alright, I wouldn't really consider this video to be part of the lecture, but as a bonus, I wanted to do a few homework questions, even numbers of course. Because as always, part of the challenge is doing the math, and part of it's just understanding what they're actually asking, like reading their language. So let's look at, I wanted to look at 4 and 10 and 18. So for 4 and for all of 1 through 10, we're trying to find the standard matrix of a linear transformation. So for number 4, we're going from 2 dimensions to 2 dimensions, from R2 to R2. It's a horizontal shear transformation. Again, you could reference those tables in the book about what a horizontal shear looks like, but we shouldn't need to because they're telling us it leaves E1 unchanged. So let's just start with that. And we'll say, E1 itself, of course, is 1, 0. And we know the transformation turns that into 1, 0. So that is unchanged. But E2, which is 0, 1, when you transform that, that does change. And it says it maps E2 into E2 plus 2E1. So let's just figure out what that actually is. We'll do a little bit of math right here. Keep in mind E2 is 0, 1 plus 2E1 plus 2, 1, 0. So we just need to first multiply so that this will become the vector 2, 0. And then add. So 2, 1. And hopefully as you get more comfortable with E1 and E2, when you look at this and say it's E2 plus 2E1, hopefully eventually you'll be able to just write that down. But I wanted to at least once say, hey, that's where it comes from. So anyway, all that to say that 0, 1, E2, the transformation turns it into 2, 1. Which means we should be able to write down the matrix, the standard transformation matrix T. So E1 goes to, same thing, E1, and E2 goes to 2, 1, and boom, we're done. And if you happen to check the horizontal shear transformation in the table, it'll show that sort of format. Okay, for 10, it says this is also R2 to R2. It first reflects the points through the horizontal x-axis and then reflects the points through the lines x2 equals x1. So we've got two transformations going on here, but keep in mind ultimately the standard transformation matrix is just about saying where does E1 go and where does E2 go. So let's figure those out. I'm just going to put my standard E1 and my standard E2 on there. So there's E1 and E2 before they transform. And sometimes it's helpful to kind of have this little unit square in here. At least I find that helpful for thinking about what actually happens with the transformation. Okay, so they say first of all, reflects points through the horizontal x1 axis. So yeah, keep in mind our old language of x and y has now become x1 and x2. So first thing that happens is we're going to reflect through the x1 axis. So the square moves, not moves down, it reflects down, I should say. So for that, it kind of moves down here. E1 actually stays the same during that reflection, but E2 now looks like this. So that's the first transformation. Kind of took a point that was here, reflected down to a point that was there. A point that was somewhere in the middle here would have reflected down to a point that's somewhere there. So yeah, it flipped over the x1 axis. And then that was the first transformation. The second one reflects points through the line x2 equals x1. And again, keep in mind, if this is helpful from regular old algebra, the language there would have been the line y equals x. So we've got this line. Let's see, what color haven't I used yet? Yellow. We've got that line, and now we're going to reflect this square over that line. So the point that was here will now go up there. Oops, up there. The whole square is going to reflect right here. The point that was here is going to reflect to about right there. Point that was down here is going to reflect to over there. And more to the point, E2 is going to reflect right here. And E1 is going to end up right there. So that's the ultimate image of E1 and E2. E1 ends up mapping onto the old E2, and E2 ends up mapping onto like the negative of E1. We don't even need to say that. We just need to say that E2, so here, let's get this down here. Sorry, let's start with E1. So E1, which is originally 1, 0, after the transformation ends up becoming 0, 1. And E2, which was originally 0, 1, so E2 is originally right here, 0, 1. After the transformation, it ended up flipping down and then flipping over. It became negative 1, 0. So the transformation matrix here is E1, the transformation of E1, and the transformation of E2. Looks like that. So that will accomplish both transformations at once. And it will move all these points over here to where they should be after they take this journey of flipping down and then flipping across. Okay. By the way, this ends up having the same effect as just rotating 90 degrees. But that's beside the point. But we could have gotten there sort of with one step instead of with two steps. Okay, let's take a quick look at 18 and then we'll be done. So for 18 and all of 17 through 20, they show that T is a linear transformation by finding the matrix of the mapping. So we're still trying to come up with the transformation matrix. And they say note that x1 and x2 are variables, not vectors, basically. So the idea for 18 is to say you're taking, or entries in a vector is how they say it. So they're taking a vector that looks like this. It has two entries. So they're taking an R2 vector, multiplying it by some matrix, and the result is an R4 vector. Notice there's 1, 2, 3, 4 entries here, which becomes x1 plus 4x2, 0, x1 minus 3x2, and x1. So part of the question over here is what size is the transformation matrix? What are its dimensions? Kind of giving it away. But notice with two inputs, that means there's only going to be two columns because it says x1 times the first column plus x2 times the second column. So there have to only be two columns. And when you multiply the first column by x1 and the second column by x2 and add them together, apparently the result is 1, 2, 3, 4, 4 entries. So this must be, each column must have 4 entries in it. And you can kind of look at the results here and see exactly how it comes out. So it's x1 times the first column plus x2 times the second column. So it looks like, at least in the first entries, the first column is 1 and the second column is 4. When you do x1 times the first column and x2 times the second column and add them, that will give you the right results there. Apparently you get 0, so that must be 0 of x1 and 0 of x2. And actually you could do something like, no, you can't. Never mind. I take that back. You'd have to have 0 and 0 there. And then for the third entries, it's 1 and minus 3. And for the fourth entries, it's 1 of that and 0 of that. So once again, there's your transformation matrix T. Okay, I think that's all I wanted to say about the homework. So hopefully that helps you, at least on those 2 chunks of the homework, 1 through 10 and 17 through 20. If you have any other questions, just shoot me a message and we'll talk.